Welcome to BioRad's Blackboard training. This is a series of short, informal tutorials brought to you by industry experts. Today we'll introduce the concept of third-party controls. The testing process begins with a patient specimen. The specimen is sent to the lab for testing. How do we know that the results from the testing process are valid? While running patient samples, labs also run samples of a known value. These are commonly called controls or QC. Controls allow the laboratory to monitor its testing systems and eliminate errors that would impact patient results. For controls to work correctly, they must act like a patient sample. For example, a blood control must be in a blood-like material. This is the same when testing spinal fluid, urine, or whole blood. Controls are shipped in liquid, freeze-dried forms, frozen, refrigerated, or at ambient temperature. Controls are manufactured as a result of one set of operations, known as production. Each production run has some variability, so it's assigned a unique lot number. Concentrations of analytes can vary from lot to lot. Control manufacturers produce many types of controls. Some controls are assayed, meaning that the values are published for all instruments. Assayed controls only give the lab initial target values. They must determine their own values by performing parallel testing on their new and old lots. Unassayed means that the values are not published. Laboratories must also determine their values for unassayed controls by performing parallel testing of new and old lots. Another way to categorize controls is quantitative or qualitative. A quantitative control is used for tests that are reported numerically. A qualitative control is used for tests that are reported with a statement like positive or negative. In the US and in some other countries, regulations state that if you run a test, you must run at least one normal and one abnormal control that day. Many labs recognize that once a day may not be enough for their lab, and they run controls multiple times a day. The lab's defined acceptable range is determined by the initial testing of normal and abnormal controls. Some easy calculations are performed to come up with a mean and SD for each control. SDs, or standard deviations, sound complicated, but if you review our Blackboard videos on statistics, you'll find that they're really quite simple. Regular testing of QC material creates a QC database that the lab uses to verify the test system. This verification occurs by comparing daily QC results to lab-defined ranges of QC values. There's a number of ways to determine if a control is acceptable. The most common approach is Westgard rules. If you're interested, check out our Blackboard videos on Westgard rules. Now that you understand some basics about controls, how can you choose the right quality control product for your lab? One consideration is shelf life. When buying a quality control product, it's important to know how much you'll use each day. A discount for larger purchases of a cheap control might be tempting. However, you'll just be wasting money if the control expires before you can use it. You should also think about clinically relevant decision levels. Some inexpensive control products don't have all the analytes at medically relevant decision levels. The price is lower, but the product provides less or no value. Box pricing is a misleading quoting practice that many laboratories fall into. Always ask for quality control product quotes on a per milliliter basis and not the box price. Participation in an interlaboratory quality control program is highly recommended. Some inexpensive control products offer inferior programs. While the previous list of considerations is important, a purchasing decision should also take into account the value of the other services provided by the manufacturer. We encourage you to pause this video and review this list. We hope you've enjoyed this brief tutorial. For all of your QC needs, visit www.qcnet.com.